Hello, I will be brief, or I will try, so we can have lunch, okay? I'm hungry too, so. As he has introduced me, I'm Nieves Barros from the University of Santiago de Compostela. I'm here to give a picture of the other colleagues about the situation of soil degradation in Galicia. So, we are in the northwest of Spain. I think 800 kilometers away from Bilbao, on the very west side in Spain. And it's a region with Atlantic, temperate, humid climate, with an average annual temperature from 8 to 14 degrees, so it's quite warm, and with an average annual rainfall from 700 to up 1,900 millimeters, so it rains quite a lot. There, forests occupy almost 70% of the land surface and competes with the pastures for cattle management and agriculture. The main tree species we have is Pinus pinaster with a 27%, 13% of Quercus robust, and 12% of Eucalyptus globulus, then with some another small percentages of different tree species. The forest management is characterized by the same problems I was hearing here the whole morning. I mean, 99% of the forest belongs to private owners, or well, are ruled by private neighboring communities. Only 1% is under a public regulation. So there are quite a lot of reasons for soil degradation, but I will focus this presentation in the ones I think are more remarkable, taking into account the forest management in my country and the characteristics of my region. So one will be afforestation due to the use of fast-growing tree species and the short rotation times, and forest fires, which is also an indirect effect of a poor, sustainable forestry management due to this fact that most of them belong to private owners. So the main consequences of afforestation and forest fires in my region is the losses of organic carbon and changes in the soil organic matter nature that has a enduring impact on climate change. About the soil properties in our land, based on the European map of organic carbon, we are classified like high carbon content, with values ranged from 5 to 10%. But the reality is that there are significant places with carbon contents higher than 12%, and that can reach even the levels of peatlands. So, what does it mean? That means that all the processes affecting those soils involving carbon losses have an important impact on the atmosphere due to the initial high carbon levels. As an example, to check or to show you a little the effect of afforestation. Afforestation has always an initial effect responsible for 50 to 60% of the initial carbon losses in the pastures that are converted from agriculture to forestry. Depending on the tree species, for example, Pinus radiata or Eucalyptus globulus, these losses take place during about 10 to 20 years in the pine stands and from about 5 to 8 years in the eucalypt stands. These losses of carbon are caused by microbial action. I mean, it's a result of the enhancement of the carbon mineralization, probably to the practices employed to convert the land or to afforest the land, together with the organic matter properties in that region. That means that at the end of the rotation of this affecting these tree species, many of the lands do not reach the initial carbon levels of the pastures that originated, of the original carbon in the pastures. It is true that we have some lands which equals, at the end of the rotation, the carbon levels of the original pastures, and some others that even present net gains of that carbon. But this happens very often. That means that after different rotations, if, for example, we are going to make more intense the forest exploitation, which is expected now since we are going to introduce the biomass production for energy, in 3 or 4 rotations, the levels of carbon could be really, really limiting, and we could have been changing very much the soil nature in our region. As I explained before, this conversion of land to forestry not only affect to the quantity of the carbon, as we have seen, but also to the nature of that carbon. That is usually not very widely researched, I think. The changes in the nature of the carbon has an direct effect in the mineralization rates. So every time we make a land use change, and every time we change the nature of the organic matter because of that, we should rebalance the carbon stocks for the global carbon balances. With respect to the fires, I can say that in Galicia, 50% of the fires in Spain takes place, and is one of the main processes associated with land degradation in my region. The main effect of forests on soil are losses of the carbon content, depending on the severity of that fire. That supposes also from 50 to 60% of losses of the initial carbon. We must think that we are talking about very high levels of initial carbon, so this is a very important effect on the atmosphere too. But not only that, after the fire, as it is a rainy country, there is a really powerful effect of erosion and additional loss of nutrients because of that erosion. So then we also have checked using some, incorporating also some innovation with the techniques we use to try to inform about changes in the nature of soil, that this fire also changes the nature of the organic matter at the end of the process. So it is very important in our land to prevent the erosion immediately after the fire due to the high rainfall, to develop the most adequate post-fire treatments, and also to make an assessment of the post-fire soil nature and their evolution in order, again, to rebalance the global carbon. So for the future trends, with respect to forestry management, it will be very important, I think, in Galicia to control soil compacting, in special to control the carbon losses by election and development of the adequate fertilizer. As an example, if we are going to use forests for biomass production with energetic purposes, that will be really, really important. And in that case, to avoid the erosion too by the election of the adequate lands where the afforestation takes place. Then it will be very important, due to the big losses of carbon we have, that could be irreversible, to keep and improve the soil fertility. And that will be to have a control of the carbon pools. When I talk about carbon pools, I mean not only the quantity of carbon, but the nature of that carbon and the different types of carbon contributing to the total organic matter macromolecule. So it will be very important to get a temporal monitorization of these carbon pools and fluxes. And for sure that involves a better knowledge about the soil properties in Galicia, for example, about the chemical contribution, or a kind of classification in base of more or less degradable fractions contributing to the soil macromolecule. And that involves indirectly the development of technology and procedures that permit to make that in a more or less affordable way. With respect to fires, we should be able to develop adequate post-fire treatments, but based on fire severity, type of soil, and properties of the terrain affected. and that is all. We can have lunch now.